Very good. Okay. So today we are going to study about the laws of motions. Okay. So first of all, can anybody tell me who is the scientist, who's the famous scientist that gave the laws of motion? Who's the one who gave the laws of motion? Yes, right. I hope all of you have heard about Newton, Sir Isaac Newton, right? So, yes, he's the same person who told about the gravitation, the force of gravitation. Done, correct. So, today we are going to study about the Newton's laws of motion to be more precise. Now, before studying the laws of motion, I have a question for all of you. Okay, what is the need to study the laws of motion? How they are useful for us? If we are studying something, it means that it must be used in our day-to-day life, or it must be used somewhere in the part of like science or engineering, etc. So where do we use the laws of motion? Can you see the usage of them, or why they are so important? Okay. Okay. So let me ask you a question first. So I think all of you must have wondered that whenever you are traveling in a car or in a bus, and as soon as the car stop, you always move forward, right? It happened with you? Absolutely. Now, also, it happened with you that whenever the car or the bus started, you move backward. You might have seen a cricketer or a fielder that whenever he catches a ball, he moves his hands backward. Absolutely correct. And also, the ball, it comes back. Why does it bounce back? Why don't the ball stop there? So all these wonderful questions, all these phenomena that are happening in our daily life, they can be answered by these amazing laws of motion. Okay, and today we are going to study about them. So basically, laws of motion, with the help of laws of motion, we can study about the behavior of the objects when they are at rest and when they are moving, with constant speed, when they are moving with variable speed, constant acceleration. So, and it also gives us the relation between force and acceleration. You all know force? Right. So let's study the laws of motion. Okay, so basically laws of motion, they are very important. They tell us about many wonderful phenomena. They tell us about the reason behind very wonderful phenomena like why does a ball bounce back? Why don't it stop there? And why do we move our hand backward? Why do we bend over? Yes, when the bus stop. So these amazing answers can be answered by laws of motion. Okay, so in total, there are 3 laws of motion. Okay, and these 3 laws, they are the basics of your mechanics. In physics, there are different branches like thermodynamics, thermal physics, optics, electrodynamics. One of the branch of physics is mechanics, and laws of motions are like basics of your mechanics, fundamentals of your mechanics. Okay, so let's first start with the first law of motion. And the first law is also known as the law of inertia, right? So let's see what is the statement for the first law. So the first law states that if every object remains in a state of either rest or uniform motion until or unless we apply some external unbalanced force upon it. Okay, every object remains in a state of either rest or uniform motion until or unless there is an external unbalanced force apply upon it. Let's say we have a box. You can see in the picture we have a box. The box in this is in the state of rest. So it won't be moving on its own. We have to apply some force. And if you are applying some force, what kinds of force it is? It is external force. External force. And what kind of force it is? It is unbalanced force. I hope all of you are remembering the balanced and unbalanced force that you have studied in the 8th class. So every object, this box will stay in its state of rest until or unless we apply some external unbalanced force on it, then it will change its state of rest to the state of motion. Now, once the box is moving, once the box is moving, now how can we stop it? Again, a moving object can be stopped only if when there is an unbalanced external force is applied in the opposite direction of motion. Okay? And this law is known as law of inertia. Now, secondly, I hope this is clear to all of you. Now, you might say that, ma'am, a ball which is rolling forward, after some time it stops on its own. A ball which is moving with some v velocity, after some time t, it stops on its own. Now, where is the unbalanced external force? We are not applying any external force. Yes, we are not applying, but nature is applying. You can see ground here, and there is an external unbalanced force, friction. Right? Friction force which is being applied here. And this friction force is the external unbalance force which is stopping this ball, or which is changing its state of motion to the state of rest. Okay. And the law of inertia is the reason why we move forward whenever a bus stops. Now let's see what is the term known as inertia. Okay, what is the term known as inertia? So inertia is the natural tendency of an object to stay in its state, whether it is state of rest or it is state of motion. So every object wants to stay in its state. No object in the universe wants to change its state. If it is in motion, every object, it wants to be continue in the motion. If it is in state of rest, then the object continuously wants to stay in the state of rest. And this property where an object resists the change in its state, it is known as inertia. So inertia, it is basically a natural tendency of an object. It is natural tendency of an object to resist change in its state. It can be state of rest or the state of motion. Now, what is the quantity on which inertia depends? Inertia depends upon mass of an object. Inertia depends upon mass of an object. The higher the mass, the higher the inertia. Let's say we have two boxes. We have a small box and a large box. Okay, and mass of the first box is m and the mass of the other box is 2m. Then, since box 1 is the box 1 have mass m and the box 2 have more mass than box 1, the inertia of the box 2 would be more. Let's understand with a practical example. Let's say you have two trolleys. Okay, you have two trolleys. One trolley is empty. Another trolley is full with groceries. Now, which trolley would be easier to move? Okay, which trolley would be easier to move? Definitely the trolley which is empty, it would be easier to move. Means it is easier to bring change in the state of the trolley which have less mass. Why? Since it has less inertia. And the trolley which is full of the objects, it has more mass, and because of that more mass, the inertia of the trolley too would be more. And since its inertia is more, it is very difficult to move that, right? Okay, now inertia is also of three types. There are types of inertia: inertia of motion, inertia of rest, and inertia of direction. Okay, let's first see what is inertia of motion. So whenever an object is moving, an object is moving, it possesses the inertia of motion. So the inertia in an object due to its motion is known as inertia of motion. The example of inertia of motion can be seen a moving bus. So when a bus is moving and you are also sitting in the bus, it means you are also in motion along with the bus. But as soon as the bus stops, you move forward. Why? Because your body has some mass, and since your body has some mass, it has some inertia. And due to that inertia, the lower part of your body comes to rest as with the bus, but the upper part, it does not want to come to rest. Why? Because of inertia. And since it does not want to come to rest at the movement, it is resisting the change. It is resisting in change. Because of that resisting change, you move forward. Okay, because of that resistant change, you move forward. So first is inertia of motion, then the inertia of rest. Inertia of rest, a bus at rest, which is starting in motion. Let's say you are sitting in a bus, you are having your cold drink, chips, etc. Right? And as soon as the bus starts, you move backward. Why do you move backward? Because of inertia again. Which inertia? Inertia of rest. Since you are in rest, your body is in rest, and because of your body is in rest, whenever the change is happening, whenever the bus is coming to motion, your upper body, your body is resisting it. And because of that resistance, you tend to move a little backward. Right? And the third one is the inertia of direction, which resists the change in the direction. So whenever the bus, it moves to the left, whenever the bus moves to the left, you tend to bend a little towards the right side. Why? Because your body is again resisting the change. Whenever the bus moves to the right, you tend to bend a little towards the left. Why again? Because your body is resisting the change in the direction. So I hope it is clear to you. So what is inertia? It is the natural tendency. It is the natural tendency of an object to resist change in its state. It can be state of rest or state of motion. Inertia depends upon mass of an object. There are three types of inertia. Inertia of motion because of the state of motion. Inertia of rest because of the state of rest. And inertia of direction because of the state of or because of the motion in a particular direction. Okay. Done. Now let's move forward. I hope inertia is clear to you. And now let's see what are some practical examples of Newton's first law of motion, which is so simple yet so useful. Okay, so the first example, the dust particles. Let's say you have a carpet, you have a mat. And whenever you beat that mat with a stick, the dust particles come out. Why? Because of the law of inertia. The dust particles, they want to stay in their state of rest, and since they want to stay in their state of rest due to inertia, they come out of the mat. Similarly, falling forward, as we have just discussed now, when you are transporting and the sudden brakes are applied, you tend to fall forward. Whenever you shake the branches of tree, that leaves get detached due to inertia. And one more really amazing fact is that because of the inertia, all satellites, they continuously move in the circular motion in the orbit of Earth. Okay, because of the inertia. Once you have given them a certain speed, they move with that certain speed because of the inertia, right? Because of the inertia. Okay. Now, I have a question for all of you, a very amazing question. Okay, let's say a boy is there. We have a boy and the boy is chased by an elephant. Boy is chased by an elephant. Now, which path should the boy take? Okay, we have three paths. You can see an elephant is running behind a boy. He has three paths to go. He can choose one out of the three paths. One is the zigzag path, then there is a straight path, and then there is a little curvy path. Okay, zigzag path, straight path, curvy path. Which part should he prefer so that he can save his life? Okay, so he should prefer the zigzag path. Why should he prefer the zigzag path? Because mass of elephant Elephant is much larger than the mass of boy. Mass of elephant is much larger than the mass of boy. And since elephant has larger mass, it has also larger inertia. It has also larger inertia. And due to larger inertia, it would be difficult for the elephant to change the direction every time. Okay, it would be difficult for the elephant to change the direction every time, because what is inertia? Resist in the change of motion, direction. Okay, and boy has less mass, his inertia is less, he would be easily able to change the direction from here to there. But since elephant has more mass, it has more inertia, it would be difficult for elephant to change his direction. And the boy, by using the first law of motion, which is law of inertia, he can save his life. Okay, he can save his life. Okay. So I hope the first law of motion is clear to you. It is very easy. Okay, now let's go to the second law of motion. Okay, so I think all of you have known momentum. What is momentum? Product of mass and velocity. So second law of motion. Second law of motion states that the rate of change of momentum is directly proportional to the applied unbalanced external force. And since we have force has some direction as well, and the direction of that force would be in the direction of motion of the object. Okay, in the direction of motion of the object. Now, it is only the statement. Let's see how we can do it mathematically. Let's say we have an object whose mass is m. It is moving constant. It is moving with an initial velocity u and uniform acceleration a. After some time t, its final velocity becomes v. After some time t, its final velocity becomes v. Okay, so what would be the initial momentum here? Initial momentum would be initial mass into initial velocity, which would be m into u. What would be the final momentum? Final momentum would be mass into final velocity, because mass is not changing here, mass is constant. So final momentum would be mass into velocity, mass into final velocity, m into v. Now let's calculate the change in momentum. Now change in momentum, it would be final momentum minus initial momentum. Change in momentum, final momentum minus initial momentum, which would be m into v minus u, because m is common here. Now from Newton's second law, what does the Newton's second law state? That rate of change of momentum, rate means divided by time, rate of change of momentum means change of momentum divided by time is directly proportional to the external applied unbalanced force. Change in momentum, m into change in momentum is m into, okay, I am just a second, students. Yes, change in momentum here is m into v minus u, time is t, let's say force is F. Okay, now what is v minus u by t? We all know v minus u by t, final velocity minus initial velocity divided by time, means rate of change of velocity. Rate of change of velocity is nothing but acceleration. So we get m into a is directly proportional to f, or f is directly proportional to ma. We'll remove the proportionality and put a constant. That constant is k. Now for mass is equal to 1 kg, force is equal to 1 Newton, and acceleration is equal to 1 meter per second square. Value of this constant is 1. If an object of 1 kilogram is traveling with 1 meter per second square acceleration, and the force applied during this duration is 1 Newton, then the value of constant of proportionality is 1. And hence we get the relation, the famous relation, that F is equal to ma, or force is equal to mass into acceleration. Okay, force is equal to mass into acceleration, and this is the mathematical result of Newton's second law of motion. So Newton's second law of motion gives the relation between force, mass, and acceleration, that how the acceleration and mass, they have effect on the force applied. Okay, what is the effect of the force on what is the effect of force on mass and acceleration? Correct? Hope it is clear to you. So what is the statement of Newton's second law is that the rate of change of momentum is directly proportional to force, not F is equal to ma. F is equal to ma is the result of Newton's second law of motion. But the actual statement is that rate of change of momentum is directly proportional to force. And if we solve this, we get the relation that force is equal to mass into acceleration. And sometime we also call this law as the as the law of acceleration. Now you must be wondering, where do we use this law of acceleration? This law is pretty well used in the cricket, right? Whenever a fielder, he catches a ball, he moves his hands backward. Why? Because what we are doing here, we are increasing the time of contact. If we suddenly stop the ball, the time would be very less. And if the time is less, the change in momentum is high, the force which the cricketer will feel, it would be very high, and he can hurt his hands. But if the cricketer pull his hands backward, the time is increased here. Time is increased here. And when the time of contact is increased during the change of momentum, ultimately the amount of force exerted decreases. And if the amount of force exerting decreases, he will not be hurting his hands. Okay, so this is our Newton's second law of motion. Hope it is clear to you. Now let's do some question on Newton's second law of motion. Let's do some question on it. So first question. Second law of motion gives the measure of which of the following? Force, acceleration, momentum, or angular momentum? Okay. So what can we find out from the Newton's second law of motion? Acceleration? No. Momentum? No. Not momentum, but change in momentum or rate of change of momentum. Rate of change of momentum. So here it is also not correct. Angular momentum, not at all. Force, exactly, because we got to know from Newton's second law of motion that F is equal to ma, where F is nothing but the force, m is the mass, and a is the acceleration of the object. Okay, now let's move to the another question. Let's move to the another question. So a bullet of mass 5 grams, we have a bullet whose mass is 5 gram. 5 gram, we need to convert it into kilogram, which is 5 into 10 to the power minus 3 kilogram. It is traveling with a velocity 100 meter per second. Means initial velocity is given, which is 100 meter per second. It penetrates a wooden block. We have a bullet which is traveling with initial velocity 100 meter per second, so high velocity. There is a wooden box. This bullet penetrates this wooden box. Okay, and it penetrates up to a distance by 6 centimeter. We need to find out what is the force imposed on the block by the bullet. Okay, so now let's do this question. So when the bullet is penetrating the block, after 6 centimeter, it comes to rest. After 6 centimeter, it comes to rest. It means that this bullet, after 6 centimeter, it is coming to stop. Its final velocity of is 0 meter per second. And we know during this 100 meter per second to 0 meter per second, it has traveled a distance of 6 centimeter or 0.06 meter. So first, by using which equation? Yes, third equation. We can find out the value of acceleration. What is third equation? V square minus u square is equal to 2as. So acceleration would be v square minus u square by 2s. What is v? 0. U square 100 square by 2. What is value of s? 0.06 minus 1000 by 0.12 or point, let's remove point, add some 0, 1, 2, 3 by 12. Okay, let's keep it here as only. Now finally we have now acceleration. We need to find out the value of force. Force is equal to mass into acceleration. Mass is 5 into 10 to the power minus 3. Acceleration is minus 10 3 by 12. Okay, we have minus 3. This would remove 3 zeros. Minus 5000 by 12. Okay. 2 6 are 12. 2 2s are 4. 0. Okay, but calculate it, students. What are you getting for your answer? Calculate it. Calculate it. I think, okay, when you divide it by 6, 6 4s are 24. 6 4s are 24. We'll get 1 0. 6 1s are 6. 6 6 are 36.66, or we get the answer minus 416.66 or minus 417 Newton. Okay, we are having the answer minus 417 Newton. So what is the minus sign what does the minus sign indicate here? The negative sign is only indicating that the force is applied in the opposite direction of the motion. The negative sign here indicates that the force is applied in the opposite direction of the motion. So what is the correct answer? Second, option 2 is the correct answer. Now let's go for last but not the least, third law of motion. So what is third law states? That very easy peasy. Third law states that for every action there is an equal and opposite reaction. Okay, means if you hit some wall or if you hit something, you will also feel the same force with which you are hitting. Okay, with which you are hitting. It means that every action, there is an equal and opposite reaction. Action reaction means the force here. Okay, and these action reaction forces, they always act on two different objects, never on the same object. Let's say we have two objects, A and object B. Object A and B both are colliding, both are traveling towards each other and colliding with each other. The force applied by A on the B means FAB, force applied by A on the B and the force applied by B on the A. They would be equal in magnitude but opposite in direction. These forces would be equal in magnitude but opposite in the direction. And this is our third law of motion. This third law of motion is very useful. You can understand about the phenomena of bouncing back of the ball. The ball applies some force on the ground. Similarly, the ground is also applying some force on the ball. And because of that force, the ball bounces back and reach towards us. Okay, so that's all for today. See you in the next class. Bye bye. Take care.